Alright, hi everyone, welcome to this new video. Today we will be building a Pokemon-like game. In this game, you'll be able to talk to an NPC, wander around the map, and defeat some monsters. Once all monsters are defeated, and you talk back to the NPC, he'll tell you that you're the champion. So basically, a simple Pokemon-like game. To build this, we're going to use the JavaScript programming language, but also the Kaboom.js library. So Kaboom.js is a very easy to use library for making games. In fact, it's very beginner friendly and a lot of stuff can get done with it in a relatively short time. Now let's get started. So before going over the project structure of our game, I'll first mention that you can find the full code for this project under the description of this video. It's going to be a GitHub repo. Now for the assets, I'll also provide links to each of them that you can download on your own to follow this tutorial. Now we have an assets folder here. Keep in mind that for the assets folder, the names of the assets aren't going to be the one I've displayed on the screen. So rename them to the following names you see right now: battlebackground.png, characters.png, and tiles.png. Now, the characters.png file is going to, of course, contain the monsters and the characters. The tiles is going to contain everything to build the environment, the map, and the battle background is going to to contain the battle background where the battle takes place. Now, create an asset loader.js file outside of this assets folder, an index.html file, and a main.js file. We will create later on other files, but I'll keep it short for now. So now go over to your index.html file. In there, copy the following code you see on the screen. I'm just going to go over it very quickly. So we have a script tag that is used to import the Kaboom.js library. I'm using the Kaboom 3000 version of this library because actually it's still in beta, but I'm using it now so that this tutorial will remain up to date in the future, hopefully. Now, once you have imported the Kaboom.js library, right below it, import the asset loader and then the main.js file. It's important to follow the orders of the script tags that is displayed on screen so that when we write our code in main.js, we'll be able to use functions from Kaboom and also from the asset loader. Now, to test that everything works, we need to first start a local server. Now, there are many options to do so, but the simplest one is to simply use VS Code, install the live server extension, and then click at the bottom right corner, the Go Live button. Now, if you go to main.js file and write some code in there, you'll be able to see the changes in the browser tab that is going to appear. Now, to test it that we can initialize our canvas properly for our game, let's go to main.js file and then call the Kaboom function. Now, the Kaboom function is going to take 3 params. So actually, you can call it without anything, and you'll see the checkered board pattern displayed on your browser tab. But I want to specify some specific options like the width and the height of the screen and the scale. Now, the width, I've chosen to go with 1280 for the width and height 720, and the scale I've decided to use 0.7. It's not mandatory that you use 0.7. I just decided to use this so that the whole screen of our game is going to fit in my dev environment. So I like having my code editor on the left side and my browser tab on the right side to see the changes. If I didn't use the scale of 0.7, the canvas would take too much space on the browser tab and part of it would be hidden while developing. Now, Kaboom.js used to have the letterbox function and the letterbox option and the stretch option so that the canvas would resize itself automatically depending on the screen size. But this isn't currently working in the beta 2 version of the 3000 version of Kaboom. Hopefully it's going to be fixed soon. I remember that it did work in Kaboom 3000 Alpha 1, so hopefully, for now it's not important as you're probably just learning how to use Kaboom, but it's a known bug, and hopefully they're going to fix it very soon, because it used to work. Okay, so just one thing I want to mention, if you see on the screen the const ktx being lined out with the red line, it's just I put this here so that you ignore it. So initially I wanted to assign the Kaboom result canvas to a variable or a constant and then do some things with it, but I decided that but in the end it wasn't really useful to do so. So really ignore the const ktx here if you see it in any other screenshots of the project of this video. Now it's time to set the background. So if you've seen at the beginning of the video how the game looked, we had a beautiful sea from which our island was on. And to have this blue color, we can set the background. So instead of drawing tiles for the background, it was much simpler to just set the background to a different color. To do so, Kaboom 3000 introduces a new function called the setBackground function that you can call. So in the main.js file, call this function, and then inside of it, so Kaboom has two options, two ways of dealing with colors. Either you provide RGB values, so one for red, one for green, and one for blue, or you provide hexadecimal values. I prefer to work with hexadecimal values because this is what is used when you look on the internet for color palettes. So to use a hexadecimal, you need to call the color interface or object or whatever dot from hex and then put in the hexadecimal string in there. And normally you should see your background changing to being a kind of blue. Now let's go to the assetloader.js function file, and inside of it specify or create a function called load assets. Inside of it we're going to start loading our assets. Now in Kaboom.js there are many ways actually two ways of loading assets. You can use the load sprite function, or you can use the load sprite at last function. The load sprite function is really handy to use when you have a single image, or so that on your image there's only a single sprite or an animation, a specific animation, so all the frames for a given animation. This is where it's useful or handy to use the load sprite function. As for the load sprite at last function, this is very handy when you have one image that contains many sprites of various different sizes, and you want to tell Kaboom to treat chunks of them as separate sprites. For example, the player down sprite that I've specified is going to tell Kaboom to start from the image x value of 0, x coordinate, y coordinate, and then cut out 16 by 16 and consider this as a single image. Now you can also specify animations within. So for the player side sprite, what I did was to simply specify the x coordinate and y coordinate of where to find this sprite, and then tell it to take a width of 32, which includes 2 frames of our astronaut character, one looking at the left and one walking at the left side. And then I use the slice x property to tell Kaboom that there is 2 frames for our animation on the x-axis, and then there is only one row. So slice y tells how many rows we have on our image that can be considered as animations, and slice x tells Kaboom to consider that how many frames there is in this given row. Once this is done, you can select the anims. You can use the anims property, and inside of it you can specify your animation. So I decided to name it walk, using the walk string for my key, and then inside of it I decided to use from 0 to 1. So the animation starts from the frame 0, so where the astronaut is looking at the left and is not moving, to 1 where he's still looking at the left but walking. And then I've decided to have the speed to be of 6 frames per second, I think. Now this might be a bit hard to understand, And the way I've figured it out was really to experiment and find which X and Y value worked to find which sprite on my image. Now, if this is still not clear, and it really isn't that important at this point, but you can watch another video I made, which is building a fighting game in Kaboom.js, where I think loading assets is much more straightforward, and this could give you a good exposure to how to load assets in Kaboom. Now let's consider that you've understood everything, or that you're going to keep continuing to watch this tutorial. So let's continue. We're going to use the load sprite function to just load the battle background. So the battle background is very easy. There's just one image. This is where it's handy to use the load sprite function, which takes in as the first param the name of the sprite. So if you go back to the load sprite atlas, you see that we had different names for our sprites here defined within the second param, but for load sprite, it's really the first param that is the name and the second param that is the path to that image, while it was the opposite, where load sprite atlas was required as the first param the image path. Now we're going to load tiles, so our tiles that we use to build our game, our map. So to build our map, I've decided to go with something very unusual. So we don't have animations in our map, but by specifying the tiles, the image, like it was an animation, we can basically use animations to change tiles. For example, I've decided to take the whole image as a single sprite, call it tiled, and then tell Kaboom that there is 8 rows and 8 frames per row. And then by using the anims property, I can specify, for example, that the rock water, so those are just our arbitrary names. For example, the first big tree part 1, which is the left side, the upward left side of the tree in our tile image, corresponds to the first frame 1. And then when we were going to use that, we're just going to call by using the play function to play an animation, but actually we aren't really playing animation, we're just telling Kaboom to select the first animation, which is the first frame for our tile. So this is going to be much more clear afterwards. Now let's go back to our main.js file and then call the load assets function here. And now we're going to create a new folder, the scenes folder, and then create 2 new files, battle.js and world.js. So world.js is going to contain the code for building our map, the map scene actually, and the battle.js is going to contain the battle scene where the battles actually take place. Now, of course, don't forget to edit the index.html file. So just copy what is on the screen right now, and in the battle.js function file, create a set battle function with the world state param. So world state is just the name of a param that I'm going to use later on to pass data between the 2 scenes. So for example, we want to be able to know when a monster has been defeated, so we can remove it from the map when the player goes back to walking on the map, so that this monster is no longer visible. And same thing for the world. Create a function called setWorld, again taking the same param world state. For now it's empty, and we're going to fill that in later on. Now go back to main.js, and then we're going to create 2 new scenes in Kaboom. So to create a scene in Kaboom, we call the scene function. The first param is the name of the scene, so I've decided to call it world. The second scene, I've decided to call it battle, and the second param is a function. Now I've decided, so it's usually an arrow function that contains the param you want, and then it's going to call the setWorld and setBattle function we've defined in the previous files. So the reason I decided to work it this way, to do it this way, instead of just providing immediately the set world function. Because if you provide set world immediately without wrapping it in a arrow function, it's going to not work, because it's going to launch the function or run the function immediately. But this way, we're basically passing a definition. So a function definition, which is going to call the set world function with the world state param. So this is some specific JavaScript knowledge. And then afterwards, after we have declared our two scenes, we need to go to a first scene when we start a game. And I've decided to just go to the world scene. So to go to a scene, you just call the go function with the world param. Now, as you've seen, here is where you would normally add a comma and then pass in the world state to the next scene. But because I'm going to make world state optional and create it if it doesn't exist later on, this is not necessary for now. Okay, now let's go back to the world.js file. Inside of it, create a function called makeTile. So makeTile is going to take a type. For now, this might not seem clear why I'm doing this, but just keep this function there and you'll see how it will get used. So just to explain things briefly, this function will provide an array of components. So in Kaboom.js, you create game objects by providing an array of components to an add function. Here, we just provide the array of components. We don't create any game objects. So I decided to provide the sprite component. So the sprite component in Kaboom is used to call a sprite. So to display a specific sprite, you need to provide the name of that sprite. So now that we have loaded all the sprites already, we can just tell it to load the tile sprite. So if you remember earlier on, the sprite atlas defines the tile sprite as being the full image, like the whole tile.png file, which contains many frames. I'm using the type here, the type param, later on to specify which of those frames we're going to use. Either the tree, left tree, top tree, grass, etc. So that's why I'm using it here. Now later on, down below, create a constant called map, which is going to be an array of add levels. So in Kaboom.js, to create a map, you don't use an external software like tiled, but you use a function called add level. Now, the reason I'm creating an array and then calling the add level function inside is we're going to have multiple layers. So for each of those layers, we're going to define the map differently. So here, the first layer you see on screen contains basically the background, just the layer above the background, containing, for example, the trees, the rocks, where things are on the map, not the characters, but just where the environment is. Now, so the grass basically, etc. Later on, we'll create a second layer, which will contain the trees. So this doesn't contain trees, I think, and flowers and other things, and then maybe the characters, and then another layer for collisions. So now in Kaboom, just general knowledge, you use the add level function. The first param is an array, which contains an array of string. So an array of string. The first param is an array of string, which contains the layout of your level, and the second param defines how each symbol will map to a specific sprite or game object. So now I've used the above layout here. I've specified that each tile is of the width of 16 and then of the height of 16 as well. And then the tiles param within the second param of the add level function will contain the mapping for each symbol. What tile does it make? So here, Kaboom will create a game object if you provide an array of components. And makeTile, if you remember, what it returned was an array of components. Here, I'm returning, for example, for 0, I'm calling makeTile and specifying that the type is grass-m. So this is just a terminology I've created for myself in the load sprite atlas function earlier on to basically describe which frame, what frame is what. Grass M refers to the grass tile in the middle, and that's grass water is the grass tile that is near the water. So if you look at the tiles.png file, you'll have a better understanding of why I named the things here. You can name them whatever you want, but I suggest that you stick with the naming convention I've decided to use in this tutorial. But for future projects, you really just can select whatever you want. So here, once you have decided on which symbol maps to what game object, you can basically in your layout use them. For example, 11111 is the edge of our map. So yeah, there isn't much to say here. Then you have to experiment, select the symbols you want, and then draw the map how you see fit. Now, after this layer, we add another layer to our array. And this time around, this is going to contain the trees and the flowers. So here, just one thing I want to mention. Make tile called with an empty no params is just going to default to the first frame. So one thing in Kaboom.js is that when you take a frame, for example, when we specified a sprite sheet animation, the default, the 0 frame, you don't have to specify it. It's just going to know that the first frame is 0. For example, if you look at the tiles.png image, you'll see that the first tile in this image is the flowers. So now 0 refers to the flowers, 1 to the big tree part 1, part 2, part 3, part 4, etc. And then I use that in my layout to draw them. So just one thing to remember, keep the same amount of spacing in your strings for the layout so that each layer is going to fit with the above layers. So if you need to keep the same aspect, like the same number of white space you use, the same number of strings you put in the layout so that things don't get out of sync. Now the third layer is the collisions. So could basically used collisions in the previous layer by just specifying an area hitbox on the game object itself, but this wasn't really flexible, and I needed to be able to specify various sizes of my of hitboxes on my map. For example, in the gameplay, you'll be able to walk above, like there's 2 levels to the map, the ground, and then you can go upward. So if you could, to make it so that you couldn't go on the right and skip basically the walking part to go to the upper level of the map, I would have to put in a hitbox here, and I did. The 222 number you see on the layout of the add level here is of the specific size of 2x16. I've decided on 2x16 to make it very thin, so that if you come from the other side, from the right side, you won't be, I don't know how to explain it, but if you were to take it, if the hitbox was the same size as the tile, the player coming from the right side would be blocked somehow and not understand why, because there aren't any visible walls blocking them. So to create tiles that have collisions, you can use the area component. Inside of the area component here, specify a shape. And here the shape is going to be new rectangle, vector2, 0, and then the width and the height. Vector2, 0, I don't know why it's there, but it's required. So just use it. Now for the body component, which is the second component used here, we're going to specify the options inside of it as being static, so that it doesn't move. So the player, when it collides with it, it's not going to move or be pushed around. So this is basically the same thing I did for all of them. And yeah, so just to reiterate, if you're watching this and you have no exposure to Kaboom.js at all, watch my previous video on making a fighting game using Kaboom.js, which is much more beginner friendly than this tutorial, because here we're using advanced concepts and I'm not going over all of what I did during the previous video. Alright, so now that we have our array with all of our layers, so yeah, just copy the code here, hoping that you've understood. One thing I've forgot to mention, what does the offset option do? So offset allows you to push your object differently from the axis. So here, no, it allows to push your hitbox, the area component, differently than where your game object is located. For example, if you want to have a game object that has a hitbox that is slightly to the right and not exactly on the game object, you have to use the offset. So here again, I suggest that you hit F1, the F1 key, when working on a Kaboom game, and you can see the hitboxes, the area components, and then you can tweak whatever values you need. Now, once you have created we have finished with all of our layers, down below, we create a for loop where we're going to iterate on that map array. And for each of those layers, we're going to use. So .use allows a game object in Kaboom.js of using a new component. So we've seen that to create a game object in Kaboom.js, we provide a list of components using mostly the add function, but sometimes it's not required, as you've seen with the add level, where the add level just needs the array and doesn't need you to call the add function. Now, you can use a new component after you have created the game object by calling the use function on that object. So layer.use, we're going to scale our tiles to being 4 times their size, so it actually looks good on our screen. Now, below this, we're going to use another for loop, and we're going this time around for each tile in that layer, we're going to first check if there is a tile type, and if there is, we're going to do a tile.play and then the tile type. So here is where we abuse the play function to, instead of playing an animation in a traditional sense, we just select a frame of we want to display. Here I selected here the frame we're going to play is actually just the frame we're going to display at all times. There isn't any animation in a proper sense. Now it's time to create our monsters on the map. So here is finally where we're going to use the add function. So we have many monsters here. So Spider-Mon, Centipede-Mon, Grass-Mon. If you've seen the load assets functions used, you're going to see those names. And we're going to use the Mini-Mons sprite. So if I go back to the sprite atlas related to the characters, you can see down below a Mini-Mons sprite, which actually contained the whole row of miniature versions of the monsters you can see on the image file. And for each of them, we used the same trick we used for the tiles to just specify animations, but those animations aren't really animations. They're just the frames we want to display at all time. So here I specified a spider frame, centipede frame, and grass frame. And if you remember the cat, which is the first in the row, we don't need to specify the 0th frame because it's the one by default. So when we call Mini-Mons by default, the first frame that is selected is the one containing the cat-looking monster. Alright, so if I go back, we create our Mini-Mons. So to create a game object in Kaboom, use the add function, provide an array of components. I provided the sprite component calling the Mini-Mons sprite. I used an area component to have a hitbox. I specify the body with the static property so that the player, when it collides with, it isn't pushed away. I've used the position component, so the component for positions. So to specify where a game object is going to be on your game map, you can use this component and specify an X value and Y value. So 400 is the X value, 300 is the Y value, a scale. So we scale this 4 times so it fits with the rest of the tiles, the map. And here I created a tag. So it's going to be handy here. So a game object can have a tag which is just a string passed in with their array of components, so that later on you can use that tag to destroy that object or do anything you want. Now I've assigned this Spider-Man game object to a Spider-Man const. Reasoning behind this is so that we can call the .play function and then specify that I want you to have the spider frame here. You can use the .flip x. This is something that Kabooms provide. Basically, from which direction the sprite is going to face. We want to flip the spider sprite because it looks by default on the right side, and we want it to look to the left. Same thing with the centipede mon, same thing with the grass mon. Now the last one, I think there's one missing, the cat mon. Anyway, just add the following. So the first, which takes basically the same components as the previous one. The only different thing is we don't need to assign it to a constant because we don't need to flip it or to play any animation because it's the default. The only difference here is really to use the cat tag because it looks like a cat, and the position is going to be 100 by 700. Alright, now let's move on. We're going to create this NPC sprite. Again, here we're using the add function. Basically the same thing, but we use the NPC sprite with the following position, and it's basically the same thing. And finally, now we're going to create our player. Now the player is going to start with a looking downwards, so we're going to use the player down sprite. We're going to specify a couple of position, body component. We don't need to provide the is static because we're going to move it, and then inside of it we're going to provide an object. So in Kaboom.js you can provide objects which can contain whatever you want and then refer to them later on. So it's basically a handy way to store data for your game object. I've decided to store a property that I've decided to name current sprite, which keeps track of which sprite is currently being used. I've decided to create a speed property to just hold the speed value, so how fast we move, and the is in dialogue property for how fast, for if the player is talking to an NPC and it's false. So the reason we want this is so that if the player talks to an NPC, we want to prevent them from moving around. So now this is how it looks like, and you can see that you can barely see your characters. So we're going to work on adding a camera so that it fixates and follows the player. Now to create a camera, we're going to use the onUpdate function, a function that is ran every, I think, 60 frames, or every 60 frames, not every frame. Anyway, I don't remember how often it runs, but it runs very frequently. And inside of it, you can just specify the cam-pause function, which is a built-in Kaboom.js function for specifying the camera position. And inside of it, provide the player.pause. So to get the position of the player, you can use the .position.pause property, which is provided by Kaboom, by the Kaboom game object, so that the camera will follow. So now if you just have this, the camera should be centered around the player. But now we need to add some other stuff. So if you've noticed in the image, the characters.png, we don't have a downward or upward walk cycle. So we don't have 2 frames for up, 2 frames for down. So how do we make our character look like they're walking when going up or down? Well, when we only have 1 frame. To do so, I've decided to just flip the frame as we walk. So to do so, this is a bit of a hack. So I would have preferred to just either put another frame on the characters.png, but this is not asset I made. So we're just going to work with what we have. So here I created outside of the update function, a tick variable. I called it let tick equals 0. So this is going to, we're going to use this variable to know when to flip the player. And then every time we go, the onUpdate function is ran, we do tick ++, so we increase the value of this tick. Now the if statement here is going to check if either is key down or is key down up. So is the player pressing the down key or the up key? Is key down is a function provided by Kaboom. If either one of them is true, we also check if the tick modulo 20 is equal to 0. So the modulo operator allows us to get the remainder of a division, and this is basically a good way to know when, for example, if you used 60 and tick is updated every frame, well, every 60 frames it's going to be equal, the remainder is going to be equal to 0. Therefore, you're going to be able to, this condition is going to be true, and then we can proceed. So this way is so that we don't flip the player every single frame. Otherwise, it's just going to freeze weirdly. So the character is just going to glitch. I've decided on the 20 value because this is what seemed reasonable. So I tested out. So I initially started with 60, then went to 30, and then to 20. And then, of course, we want to see if the player is not in dialogue. So by using the third condition, if the player is in dialogue, if the player is not in dialogue, we want to allow the player to move. If they are in dialogue, we don't want to. So this is why we use the bang here, so that we have the reverse of the condition we want. So the reverse of is in dialogue. Now, if all those conditions are met, we can just use the player.flipX property, and we can modify it by just taking its contrary. So if it was flipped leftward, it's going to be flipped rightward, and etc. So this is going to give us the illusion of the character walking. So that's voila. So you can see it works. So that was a cool trick to be able to have a downwards and upwards walk cycle. Now we're going to work on the player movement now, so that the camera follows us. So now we're just basically stuck in one place. Now to do so, I first created a setSprite function. So the setSprite function is going to basically change the sprite when we want. It's a utility function I just created so that we don't have to repeat ourselves later on. So it takes in the player game object and the sprite name you want the player to change. If the player.currentSprite, if you remember earlier on, we created a game object, the player game object with the various properties, custom properties, and one of them was the current sprite. So if the current sprite is not equal to the sprite name we want to use, then we use the use function and change the sprite to being the sprite we want, and then update the current sprite property to reflect this change. Now, for movement, we can use the onKey down function to listen for keys. So here we have the same code, one for down, one for up, and we move our player using the move function. So I'm going to go over the onKey down function here with the down key. So the first param is the key. The second param is a function that is going to be ran or is going to run when the key down is pressed. So if the player is in dialogue, we do nothing. We return immediately so that we don't change sprite or allow the player to move. And we set the sprite, if it's not the case, so the player is not in dialogue, we set the sprite to being player down, so the player looks downward, and we move the player using the move function. This is provided by Kaboom, and it takes two params. The first tells Kaboom how much to move horizontally, so from the x-axis, and the second tells us tells Kaboom at what speed to move up vertically. So the first param is the speed for moving horizontally, and the second param is the speed for moving vertically. So here, if you remember, earlier on we had a custom prop called speed for our player, and I've specified it to 300. So here we call it to use it. So here, by putting it as the second param, the player is going to move downwards. So remember, in game development, the farther you go down, the farther, the more the Y value increases instead of decreasing. Now, the same thing for on key up, on key down with the up key. So I'm not going to cover it. What I'm going to cover is the different case with the on key down left and right. So on key down with the left key, we do the same thing. So player is in dialogue. If yes, we return immediately. Then we don't flip the player because the player is by default looking at the left side. If the current animation though is not the walk animation, because now it's not just about changing sprites. We need to change sprite and play the walk animation. As with the up and down sprites, we didn't need to do that because we wrote some logic in the onUpdate function to take care of flipping and making it look like an animation for the up and down movement of the player. But here we need to check this. So if player.curAnim, curAnim is a function provided by Kaboom, which basically gives you the current animation that is being played. If it's not the walk animation we specified earlier on, then we make sure to first set the sprite to being the player side in case it isn't set, because we can arrive in a case where we are moving leftward but some other sprite was changed. But if you use player up and then try to play walk, but walk is not defined for player up, then it's going to fail. So we make sure to set the sprite to being the player sideways and then use the walk function, because the walk function animation is defined for the player side sprite. And then here we move the player to the left by using a minus player.speed. So this is very straightforward. Same thing basically for the right, so I'm not going to cover it. Now on key release left and on key release right. So if the player releases the key while moving left, we want to immediately stop the animation. Same thing if we do it on the right side. So that's basically straightforward. And now you could be able to, you can see that you can move around the map. And of course, you can also notice that the collisions are actually working by pressing F1, and you can collide with things. And so voila, so everything is working. Now, the next thing is we're going to specify the world state variable. So if world state is not defined, so earlier on, we created a param for our scenes that was called world state. And when we first launch the game, world state is not defined, as we use the go function using only the scene name and not using any second param which would pass in the world state. So in that case, so if it's the first time that we play the game, or if we just launch the game and just arrive on the map, world state shouldn't be defined. And so we're going to create it to assign the player position. So we're going to assign an object to the existing variable, but that is undefined or null. So we're going to create an object here, specify the player position so that when the player battles and then comes back to the map, he starts at the same place he left and not go back to the initial spawning point. And the fainted mons array, which is going to contain the names of all defeated monsters. And this is useful because for the NPC to know if the player has become a champion or not. And then after that, so after this if statement, we need to make the player position being equal to the world state.player position. So in the case that the world state existed, was defined, then we want to immediately just make the player position fit with this, what the world state has. Because if you remember, we have two cases. The first case, the player starts the game. He's immediately transported to the map, so there aren't any previous world state. However, if the player goes from wandering around the map and then battling with a Pokemon monster, then we keep track of the world state, and when we're going to go back to the map, we're going to pass in the world state, which contains a new player position, which was the previous player position the player had before entering battle. So that's why we had this if statement previously, and that's why also we set the player position to be equal to the world state.player position. And now here we need to specify the vector 2. So the player position takes in a vector. I don't think it's necessary, but anyway, try it without the vec2 here. If it works, I just forgot to remove it. But if it doesn't, I don't know why, but just so that I know that the player.position component needs a vector too. Anyway, now we have another for loop here. This is where we check if we check where the fainted mons, so the defeated monsters, if there are any defeated monsters, and if there are, we destroy them. So to destroy something in Kaboom, you call the destroy function, and here you can also use the get function, pass in the fainted mon. So fainted mons here is just going to contain an array of string of the name of the various mons here, and the name is the tag. So if you remember earlier on, we specified tags for our monsters, and this is going to be useful here so we can delete them. So the get function by default returns back an array with all objects it found with the tag provided as the param. But here we're pretty much sure that it's going to be only one, so we just do a brackets 0 index 0 to just check, just provide the fainted mon at index 0. So we destroy that one. Now we're going to work on the player collisions with the NPC. So when the player collides with the NPC, we want to start a dialogue. To do so, here again, the same thing. So player is in dialogue, we set it to true. And then we create a dialog boxed fixed container. So one issue I had when working on the game is that the array, not the array, the box, the dialog box would move around as the player would move after dialogue, or depending on where the player would initiate or collide with the NPC. And that was because we have specified the camera to follow the player, and we need to make it so that the dialog box is fixed. It doesn't move, it doesn't depend on the camera. To do so, we need to first create a fixed container, boxed fixed container, which is an empty game object with just one component, the fixed component. Then inside of it, and after it, we create a child to this component. So to create a child of a game object, we just use the add function after the game object. So for example, dialog box fixed container is a game object. We use the .add function to it to add another object. And then I've decided to just store the resulting game object, which is a child of the dialog boxed fixed container, to the dialog box constant. So here again, we use the fixed here. So this is going to be our dialog, how the dialog box looks. So it's a rectangle, it's white, it has an outline. So the outline component, which provides you with an outline around your game object, usually black, and then position, and then again, we call it fixed. So we want it to be fixed on the screen, not dependent on the camera. Here I created a dialog constant. So here you defeat all monster on the island, you become the champion. Then I created another game object. This time I called it content, and it's a child to the dialog box, which takes in the text component, which the first param is a string. I've decided to put it empty because we're going to modify it later on and put various dialogues and stuff. And the second param for this text component is the size, the width, line spacing. Those are the params you can provide. Then the color, I decided to go with RGB here and select a near black color, just so it's easy on the eyes, a position, and fixed again. Now here, what comes after is I'm going to use an if statement. If the world state.faintedMons is inferior to 4, then we assign to the content game object the text that we specified in the dialog const. So the basic dialog when you start the game that tells you to defeat all monsters. Now the reason I selected to be inferior to 4 is because on the map there's only 4 monsters. So once you've defeated them all, so that means the world state.faintedMons array is going to be higher than 4, then the text is going to change. So when you talk back to the NPC, it's going to say you're the champion. Now here again, I'm going to use the onUpdate function. So onUpdate is really a function you can call everywhere. So here, we're just going to make sure that when the key is pressed, the is key down, space is pressed, we're going to destroy the dialog box, and then players in dialog is going to be false. So here, it's different. So we use the is key down function, which returns a boolean here. And then depending on the result, we destroy the dialog box. The reason I'm putting the onUpdate here is because I need to, in order to access to the dialog box game object. Otherwise, if I've put it outside of the onCollide function, it wouldn't know, dialog box would be undefined. So now, if you talk to the player, it's going to be defeat all monster on this island, and you'll become the champion. So that's basically it. You can see that the positions of children in a game object are relative to that to the parent game object. So that way you can know how to space things so that your text looks great. Now I'm going to create 2 functions, one called flash screen and one called onCollide with player, to handle when we're going to start entering battle against the monster. Okay. So the flash screen function contains one component, which is a big rectangle, and then it's fixed and the opacity is 0. So we're going to play with this opacity and change it as to have the flashing effect. And this is where we're going to use the tween. So tween is a new function in Kaboom that allows you to tween. So have a smooth transition of a value. So here I've decided to provide, so the first thing you need to provide to the tween function is the value you want to change, the target value. So here I want to change the opacity of the flash. Then I want it to go from 0 to 1 in 0.5 seconds. And the function that is going to take care of updating the value is this arrow function, which is going to assign the flash opacity to be equal to a value. And the type of easing or smooth transition is going to be ease and bounce. So there are plenty of types of easing you can use specified by Kaboom. I suggest that you look at the documentation to see which fits the game you're making or the effect you're looking for. Ease and bounce is going to basically go up and down twice, so that's going to provide the flashing effect that you see in Pokemon games. Now, the onCollide with player function I've created is going to take the enemy name, so basically the enemy tag, the player, a game object, and the world state, and then it's going to be called the player onCollide function with the enemy name, which is the tag of the monsters I'm going to use, and inside of it is going to first flash the screen, then set a timeout. So we want to let the screen flashing before we change scene. And using the set timeout functions allows us to do that. So the set timeout function is basic JavaScript. So it's going to run the code within after 1000 milliseconds or any number of milliseconds you provide as the second param. Here we specify the world state player position as the current player position. We specify the enemy name here, So this is a new property that wasn't specified earlier on, so that the battle scene will know which enemy, which monster to display on the screen. And then the go function here is going to go to the battle scene, and then as the second param is going to provide the current world state. And then basically that's the thing. We call this onCollideWithPlayer function for all of our monsters here. Those cat, spider, centipede, and grass. And we're set. Now we're ready to work. Now if we look at the result, you collide, there is a flash, and then there is just a blue background because we haven't written the code yet for the screen, for the battle. So go to the battle.js file, and inside the set battle function you created earlier on, just add the battle background sprite. Here again, I decided to use a 1.3 scale here, just so that the battle background fits the screen. And that's basically it. Here we're going to create a new game object called the enemy mon. This time around we want our enemy monster to be bigger, to use the bigger sprite as you see in Pokemon. And here again, nothing new here. Specific opacity specified to 1, and just one custom param, which is if the enemy mon is going to be fainted. And we want to flip it, so we want the enemy mon to look at the left side, and our monster that we're going to use to battle is going to be looking at the right side, just like in Pokemon games. Now we use again the tween function, but this time around we want to have a smooth transition from the left side, from the right to the left. Here again we used an easing sign instead because I thought it would fit better here. So if we look at the result here we go, the monster comes in very smoothly. We do the same thing with the player mon, but on the other side, as I've explained. So I've explained how tween works. So the first is the value you want to change, the variable which contains the value you want to change. The second is the target value. The third param is in how much time it's going to reach that value. The fourth param is the function that is going to modify this value, and the fourth param is the type of easing you're going to use. So now if we look at the result with both our player and enemy mon, it's going to, well, before doing that, we're just going to work on our health box. So what is a Pokemon game without health? The health box that appears. Here again, created the player mon health box, added the children to it. Our monsters the player is going to use is called, I called it mushroom somehow. So we're going to use this. We display the text. We have two health bar. Two children to the health box. The first one is the gray bar, and the top of that is the the actual health bar that is going to diminish and is of green color. And it's the const player month health bar here. So here I assume you can basically decipher the code. So I'm not gonna go over each of those lines. So hopefully I've made my explanation already clear so you can understand what is going on here. Same thing for the enemy health, enemy mon. This time around the tweening is different, so that instead of going from the left, so the enemy health box is going to come from the left side to the right, and our health box continuing, our health bar is going to go from the right to the left. Now once this is done, we only need to create our dialog box, so which contains the dialogue of the battle. For example, mushroom is ready to battle. Here is how I did it. Copy this code and you should see that it's going to work. Now if we launch our game and go into battle, you'll see the cat health bar, mushroom health bar, and it looks a lot more like a Pokemon game. Here I've decided to scale usually it's frowned upon to scale pixel art differently like that, so you might not want to do this, but I've scaled our player monster to be slightly bigger than the one of the enemy earlier on. Yep, so that's that. Okay, now I'm going to create two functions. the reduce health function, and the make mon flash. So each time a monster is hit, we want it to flash, a bit like in Pokemon games, so that it feels like it took damage. And we also want to reduce the health. So to reduce the health bar smoothly, again, we use tweens, and it's basically tweens all the way. So we use tween for reducing the health, we use tweens for making the mon flash, and for the reduce health, there's nothing special here. So I'm just going to focus on explaining how we make the mon flash. So the mon flash here, the function that takes care of changing the value during the tweening, is going to change the tweening, and if we reach 0, because I've put the target as being 0, we're going to put it back to 1. So we want the enemy or the monster to flash, but not to disappear completely. So we want it to go back to being fully visible after taking damage. So that's the reason for setting it back to 1 when it's done. Alright, so now it's time to build the combat. So how the combat works, turns works. Here I've really made it simple on myself to not have a complex battle system. It's basically just tackle. Pokemon's monsters are just tackling each other rather than having complex move. So you use the space key to play the game during battle. So I've created a phase variable which describe in which phase of the combat we're in. For example, we start at the player selection phase. So when the player presses the space key and neither the player mon or the enemy mon is fainted. If it was the case, we would just do nothing. So we don't want to arrive in a case where we allow the player to continue dealing damage to a dead enemy monster. So that's the reason for putting this if statement here. Now, if we are in the player selection phase, we change the content text to basically display a choice for selecting tackle, and then change to the phase to being player turn and the return early. Now, next time the player presses the space key, it's going to go from player, it's going to go immediately to the player turn phase. Now it's down below, you can see in the screenshot, but before that I've specified the enemy turn. So what happens when the turn is on the enemy? Well, we're going to basically write some text to say that the enemy is attacking. We're going to randomly select a damage value by calling math.random on 230. You could have decided how the value here is not important. Now, if the damage dealt is superior to 150, it's a critical hit, I've decided. So, yeah. And then we reduce the health. We make the mon flash because it took damage. So we reduce health of the player monster. We make the mon flash of the player monster's monster. The player's monster is the one who's going to flash. And then we go back to the phase being player selection and we return early. And then if we were on the player turn, we do the same thing, but this time around it's the enemies that is going to flash and have its health reduced. And then the phase is going to be the enemy turn. If we look at the combat, we have its critical hit. So if we look at the combat, we enter combat, we do tackle, it's a critical hit, and then tackle again, etc. Now what would be really nice is if we could colorize the health bar differently. So when the player health bar is near depleted, we color it red. When it's mid, we call it yellow, a bit like the Pokemon games. And for this, I've created two functions. Actually, one called colorize health bar. It's going to color the health bar by telling the health bar to use a specific color component if the health bar dot width. So we've been reducing the width of the health bar in order to signify that the player has taken damage. But instead of just using this to be visual, we also treat the width as if it were the actual health of the player of the monsters. So that way, it's easy to handle instead of having a separate variable for the health and a separate variable for the width. Instead of having to create another variable for the health and dealing with the health separately, I've just decided that the width of the health bar is also the health. Also should be treated as the health, the actual health. Now, in an actual real game, you might not want to do that, but you know, I just took the easy way here. Now, when the monster is dead, we want it to drop from the screen, a bit like in Pokemon. So here again, tweening, we go from the current position, Y position, and then we drop to 800 Y values. So this should be out of the screen, so the player shouldn't see the monster anymore. Now we're going to use a last on update function here. I'm going to colorize the health, call the colorize health bar for both of our players' health bar, enemy mon and player mon health bar. Then we're going to handle what happens when a monster is dead or fainted. So if the enemy mon health bar is dot width is inferior to 0, that means it's dead, and we haven't considered it yet to be fainted, then we're going to make the mon drop, update the text to signify that the monster has fainted, then set the enemy mon dot fainted to be true, then do a set timeout and update the text to signify that the player has won, and then another set timeout, but just 1 second after the first timeout to push that to the world state that this monster is dead, and go back to the world, but this time around with a defined world state. Same thing with when the player is the one to die, the player's monster is the one to be fainted. Basically the same logic, but this time around we update the position, the player position, to be near the spawn point. So when the player loses, we want to respawn the player where they initially spawned instead of going back to exactly where they were. Because here we specified that you rush to get mushroom healed, and we assume that you got to heal your monster near the NPC or something like that. So now here's the full gameplay. I've talked to the NPC, enter battle, I fight the first monster. It's a critical hit. It becomes orange, yellowish, red, and a cat enemy has fainted. Now it disappears from the map. This is because of the world state. Then we fight the centipede. Same thing. Hope we win. And yes, I think we're going to win. And we won. Yep. Oh, no, not yet. And then voila, the enemy mon faints and drops. We fight the spider now. This is just a full gameplay. So just so you can see that once we've beaten all the monsters and we go back to the NPC, the dialogue is going to change. And here we fainted, so we have to go back to battle the spider. Hopefully we win this time. And we win. Alright. And then finally the grass monster, which is the last one to defeat. And voila, so tackle again. I think we're going to lose here. Yes, we lost. So here again, you can see that we spawn where we initially spawned and not near the grass monster. It's a critical hit. We tackle and we should win. Alright, we won. And now if we talk to the NPC, they're going to say that you're the champion. And that's basically how to make a Pokemon-like game in JavaScript using the Kaboom.js library. Hope this was useful. Subscribe for more content related to JavaScript and just programming in general. And voila, so I have another tutorial, fighting game tutorial using Kaboom.js, which I think is much more beginner friendly than this one. So I would recommend that you watch this tutorial if you want. Thanks for watching.